Hello everyone, my name is David Tucker and welcome to the course Fundamental Cloud Concepts for AWS. I am a cloud consultant and I help organizations plan, build, and implement custom software solutions in the cloud. I have over 15 years of experience in software architecture and development, and during that time, few things have fundamentally changed computing like the cloud. AWS certifications add value for both technical and non-technical resources in today's digital world. In this course, I will walk you through the fundamental cloud concepts of AWS. The knowledge in this course covers one of the 4 major areas that are required for the AWS Certified Cloud Practitioner exam. First, I will review the concept of cloud computing and the value that it provides to organizations. Next, I will review the organization of the AWS global infrastructure. Next, I will cover the economics of cloud computing. And finally, I will review the tools and services that AWS provides to support infrastructure running on their platform. When you finish with this course, you will have a clear understanding of the cloud and the fundamentals needed for a part of your AWS Certified Cloud Practitioner exam. Welcome to Fundamental Cloud Concepts for AWS. My name is David Tucker, and I'm going to be guiding you through this learning path to help you get ready for the Certified Cloud Practitioner exam. Now, this is a learning path, and it is designed to be a one-stop shop for you. It has everything that you need to get ready for the exam. This includes video courses to give you information on the topics that are covered on the exam. It also includes study materials, and I'll give you instructions for each course on how you can access the study materials for that course. It also includes an exam prep course, and this is what I am most excited about. This course will not just help you through sample questions, it will walk you through and teach you how to think about the questions. It has 2 complete sets of sample questions that you'll be able to go through to help get ready for the exam. So be sure you go through all 4 video courses. Use the study materials that are provided and go through the exam prep course, and then you'll know if you're ready to take the Certified Cloud Practitioner exam. Now, for this course, if you want to access the guided notes, you need to go in with your browser and go to this course. Then look for the Exercise Files tab and download those files to your computer. This will be a zip file, and inside of this zip file there will be several folders. Go into Module 2 and you'll find the guided notes. Now, the guided notes are designed to be printed out so that when you go through this video course, you can write in content as we cover it. Now, just in case you missed something, there also is a completed version of the guided notes also included with this course. Now, these are designed to help you as you're going through this course, but also serve as a study guide that you can go back and review before you take the exam. I'm excited to go along with you on this journey to becoming an AWS Certified Cloud Practitioner. So next, we're going to walk through the process of creating your own AWS account. And this can be extremely beneficial as you're going throughout this course to be able to follow along and actually experiment within AWS. So in this demo, we're going to do 3 things. First, we're going to create a new personal AWS account. We will then activate the new account. And then finally, we will be configuring a budget alert for the account, so we can make sure we don't have any unexpected charges that end up growing on our account. So I'm going to go ahead and go through the process of creating an AWS account. Now, I'm here on the AWS homepage, and it'll probably look different depending on when you're looking at it, but you should see at the top right a button that says Create an AWS account. So I'm going to go ahead and click on this option. Next, we're going to need to put in 2 different pieces of information. First, we need to enter in a root email address. Next, we're going to need to give this an AWS account name. Once this is in place, we can now click Verify Email Address. And so here, it's going to send something to your email address, and you'll need to enter in the verification code. Now that I've entered in the code, I can now click Verify. Great, now it's telling me my email address has been verified, and now I need to create a password. Once the password is in place, I'm going to hit Continue. From here, it's going to ask if I want this to be a business or personal account. So I'm going to assume that most of you, in walking through this course, just want to create a personal account that you can test as you're going through this course. So I'm going to click Personal. I'll enter in my full name, I'll enter in my phone number, and then I'll enter in my address. Now that all of that information has been entered in, I need to agree to the terms of the AWS customer agreement, and then I can continue. Now here, it's going to be asking for my credit card information, and it's important to note here, AWS is a service, and when you utilize this service, it may charge your credit card. However, it's letting you know here that there is a free tier where there are many different services you can try out without having to pay anything for those services within given limits. So keep that in mind, and in just a minute, we will set up a billing alarm so you shouldn't have any big surprise charges that end up on your account. But for now, I'm going to go ahead and enter in my credit card information. Now the next step is confirming your identity, and it's going to do this by sending either a text message or a voice call to a mobile number that you specify. So I'm going to go ahead and enter in my mobile number. The next thing I'm going to need to do is I'm going to need to pass the security check. So here I'll enter in the characters that are on the screen, and then I'll hit send SMS. Now I'm going to enter in the code that I received on my phone, and I'll hit continue. Now the next step is to select a support plan, and don't worry, later on within this course, we'll walk through each of these support plans in detail, but for now, we will just stick with the basic support option and hit complete signup. Now, congratulations, we have completed the creation of an AWS account. From here, I can click the option to go to the AWS Management Console. I'm going to specify here that I want to sign in as a root user, and I'm going to give the root user email address. Then I'll hit next, and I need to enter in the password. Now I'll hit sign in. Now I am here within the AWS console, and this is the way that I'll interact with AWS from my browser. But the first thing that we need to do is to set up the billing alarm so there aren't going to be unexpected charges that end up on the account. So I'm going to click under the name of the account, and I'm going to go to the option here that says Billing Dashboard. Now that I'm here, I'm going to go here under the left pane and go down to the option that says Budgets. From here, I'll specify that I want to create a budget, and I'm going to select the option here that says Use a Template, and then I'll go to Monthly Cost Budget. I'll specify here that my budget amount is going to be $10. You could specify a lower amount if you would like. I'll leave the budget name that they specify here, and I'll specify the email addresses that I want it to notify once the notification threshold has been met. So you'll notice here that all AWS services are in scope in this budget. We will be notified when our spend reaches 85% of the total amount, which in this case would be $8.50 for 1 month. Also, we'll be notified when our actual spend reaches 100%. So with that being said, we can say create budget. Great. Now we have a budget in place with notifications to let us know if our costs are even approaching the budget that we've specified. Now we should be able to take advantage of many of the free tier services without having to worry about costs, but you shouldn't have to worry that you would have costs growing without being notified. Now next, we're going to talk through how organizations leverage traditional data centers. And so we're specifically going to be focusing on organizations that have not yet shifted to the cloud. And we're going to be starting with a fictional organization called Globomantics. And within Globomantics, there is a group that has decided that they should launch a new social network for professionals as a new line of business for the organization. Now initially, they're focusing on the United States at launch. And if they're successful, they are looking to expand into Europe and Asia. Now, they're currently working to secure funding for the initial infrastructure because it's going to cost a good deal of money to build up the initial data center. So let's begin to play this out. So here at Globomantics, they were able to secure an initial round of funding. And since they're located in Nashville, they built a data center in Nashville. It took 5 months from when they started to when they were actually able to move in. And once they were able to load their servers in, they knew they needed several types of servers. They needed some web servers so they could serve their content out through their website. They needed some file servers so that they can store user uploads like profile pics. And they also needed a database server so that they could store user information like messages and who their friends are. Now they had a great launch in the United States, and they feel like there is a lot of growth ahead, so they want to plan a move into Europe. They specifically want to plan to move into Dublin. However, once this process starts, it's going to be another 6 to 7 months for them to be able to move into that new data center. Now, because of this, they need to go through that entire process and secure more funding, and they need to order some more servers. After 7 months, they're finally able to move in some servers in their data center in Dublin as well. But they don't want to just stop there. They also want to move into Asia. But something unexpected happens. They have tremendous growth in the United States, and they need to expand their data center in Nashville. So they're able to go in and add some more servers. But once that demand happens, it takes them at least a month to order the servers, get them there, get them installed, and configured. So during that time, several users were experiencing performance issues with their social network. Now, once all of that's in place, they're finally able to shift their attention to the data center in Asia, which is going to be in Singapore. And it takes another 6 months to begin to get that in place and to order servers, and they then deploy their servers in Singapore. But something happens. Users that were interested in the platform in Singapore have already moved on to something else. And so they have all of these servers and their data center sitting there in Singapore being barely used, and they have put a significant investment in getting it up and running. Now, let's pause on Globomantics for a minute and let's take a look at what we've learned. First of all, when we're looking at traditional data centers, it takes an initial upfront investment, and a pretty large one at that. Organizations have to plan to either build a new data center or rent space within an existing data center. Next, forecasting demand is difficult. Even the best organizations struggle at this, understanding how many users are going to latch on to a new solution, whether it's an external one like a social network or even an internal business application. Next, it's slow to deploy new data centers and servers. So not everything can be ordered overnight via Amazon Prime, and so there are times when it will be very difficult to get up and running if we need to respond to a change in demand quickly. Next, maintaining data servers is expensive. So with Globomantics, for every new data center that they spun up, they're going to need to add dedicated resources, dedicated individuals to maintain that server infrastructure at each of those data centers, and that's a cost that's ongoing. And next, you own all of the security and compliance burden with each of those data centers. So nobody wants to get hacked, and nobody wants to be sued for being hacked. But if you're an organization owning those data centers, that entire responsibility rests on your shoulders to be sure that you're following all of the industry best practices. So now, with this said, we're next going to look at some of the benefits of cloud computing. So next, we're going to talk through some of the benefits that you get with a paradigm shift to cloud computing. So AWS calls out several key advantages. The first of them is you trade capital expense for variable expense. Now let me break that down a minute for you. What that means is we don't have this large capital investment initially to build out a data center, like we talked about with Globomantics. In this case, we get a variable expense, meaning that if we're using a server in the cloud, we simply pay for the amount of time that we're using it, and we can throw it away at any point. Now we're going to talk a lot more about the economics of the cloud later within this course. Next, we get to benefit from the massive economies of scale. So this really factors in two different areas. One is just the cost of building out a data center and all of the equipment involved. AWS buys things on a very large scale, and so they're able to make sure that they're getting the best price for those. In addition, in the economy of scale, when we look at it from a maintenance perspective, Amazon has determined how to manage all of these fleets of servers effectively at scale. And so those cost savings get passed down to us as consumers. Next, you can stop guessing capacity. We talked about with Globomantics how difficult it can be to properly predict demand. Well, what if you just didn't have to? What if you could choose to have a system that could either grow or shrink based on demand? That's one of the paradigm changes you get with cloud computing. Next, you get to increase speed and agility. So when we talked about Globomantics in the previous clip, we mentioned that they were looking to find funding partners before they were able to go out and test their social network. Well, that's not very agile. Ideally, we want to be able to test out our hypothesis against real users and to do it quickly. And one of the things you can do with cloud computing is try out new ideas and have minimal cost to do so. Next is you can stop spending money maintaining data centers. So as I mentioned with Globomantics, they were having to staff individuals at each of the data centers. And at each of the data centers, they would own that maintenance burden for as long as the data center was up and running. And so this allows you to shift away from that. And next, go global in minutes. So in the case of Globomantics, they were having to wait 6 or 7 months to move to a new region within the world. However, what if they could simply send data over to Singapore or to Dublin at any point without having to build out new data centers? They literally could do it within minutes instead of within months. Now, with these advantages, I want to focus on a few key terms that you need to be familiar with. The first of them is the concept of elasticity. And this is what we talked about earlier when we were talking about demand. But it's the ability to acquire resources when you need them and then release them when you no longer need them. And in the cloud, you want to do this automatically. Now, AWS has several services available to you to do just this, and we'll talk more about these in the next course in this path. Now, the next concept I want to talk about is reliability. Now, when we talked about Globomantics, one of the things that we didn't even cover within their data centers are things like failover. So what happens if one of your data centers goes down? Well, one of the advantages of AWS is that it has global infrastructure that is built with reliability in mind, because we want our solution, whatever it is, to always be available to our users when they need it. And so we can take advantage of this by building a solution on AWS. And the next concept I want to talk about is agility. Now, as I mentioned, we want to have the ability to lower the cost of trying new ideas or business processes. So instead of having to go out, for example, let's take a new concept like blockchain. Instead of having to go out ourselves, hire individuals that have their expertise, buy the hardware that we need, install it in a data center, and then start using it. In this case, we're simply able to tie into the resources that AWS has and use the services that they provide to us. Next, it reduces the time required to maintain infrastructure. So we begin to shift. Instead of simply spending time maintaining, we're able to spend time working on things that add business value. Next, it does reduce the risk for the organization around security and compliance. Now, don't let anyone tell you that you don't have to think about security when you move to the cloud. You certainly do. And we will be looking later at the AWS shared responsibility model, so we understand what is our responsibility and what is AWS's responsibility when it comes to security and compliance. And next, it provides access to emerging technology, as we mentioned earlier with blockchain, without having to spend a ton of money to ramp up on that new technology. So now that we've gone through and discussed benefits of using cloud computing, let's now take a minute and talk about different types of cloud computing. And before we dive too deep into that, let's discuss a definition for cloud computing as a whole. AWS says that cloud computing is the on-demand delivery of compute power, database storage, applications, and other IT resources through a cloud services platform via the internet with pay-as-you-go pricing. And that pay-as-you-go pricing is critical, as we discussed in the previous clip. Now let's look at some different models of how we use cloud computing. So let's imagine for a minute that we have a spectrum. And on this spectrum, on one end, we have absolute control, but on the other end, we have minimum maintenance, where things just run without us even having to think about it. Let's imagine 3 different points on this spectrum. First of all, on the far left, with maximum control, we have infrastructure as a service, or commonly abbreviated as IaaS. This is where we run servers in the cloud, virtual servers, that are very similar to how we would run servers in our own data center, meaning that we have full access to those servers. We can change the OS that's running on them, we can completely configure them to do exactly what we want. However, we also have to perform maintenance on those servers, keep them up and running to do exactly what we want them to do. But then if we go to the far right of the spectrum, we end up with something else, and that's software as a service, or SaaS, commonly abbreviated as SaaS. Now, for software as a service, you might not realize it, but you're probably using multiple software as a service solutions every day. And that could be your email provider, or that could be your specific chat service that you use with other employees. It's just a piece of software that you're able to run with. You don't have to worry about configuring servers. It is just provided to you as a service. And in the middle of these two, we have something called Platform as a Service, or PaaS. And this means that we're given a service that is configured for us where we simply need to deploy our customizations onto it. And so if you've ever used maybe a WordPress host like WP Engine, you can simply drop in your code and you can be up and running. They configure the WordPress install in the server for you. That's a good example. There also is a platform as a service solution on AWS called Elastic Beanstalk. So with these different options, we can understand that there are different ways to use cloud computing. Now next, let's talk about different cloud deployment models. Now the first model that we see here is public cloud, or sometimes people will just say cloud. And this is when you are deploying a solution onto a public cloud provider like AWS. And there are others here as well, like Azure from Microsoft or the Google Cloud Platform. Next, we have on-premises or private cloud. You'll also sometimes hear people say just on-prem. And this is when you have a cloud-like platform in a private data center. So if you wanted to be able to be somewhat scalable like you have with AWS, but you wanted to be able to do it within your own data center, there are solutions that you can deploy from companies like VMware, for example, to have a private cloud. And in some cases, you will have what we call hybrid, meaning you have an organization that is leveraging both a public cloud, but those public cloud applications are working in tandem with a private cloud within their own data centers. And so it's important to understand that for some, especially large organizations, they could be using both a public, private, or using them together in a hybrid model. So next, we're going to run through some scenarios that are based on what you learned in this module. Now, we'll be following this pattern for the remainder of the courses in this path. So we'll present the scenarios here in this clip, and then in the next clip, we'll be running through the solutions. That way, we'll give you time to think about the answers. So let's look here at scenario 1. We have Roger, and his company runs several production workloads within its data center. Now, they use VMware to manage the infrastructure in their data center, but they want to use AWS and they want to integrate it in with their data center for some of their new workloads, so using the two in tandem. So in this case, which cloud deployment model would his company be following? Okay, let's look at scenario 2. So here we have Eliza, and her company is trying to decide whether to fund a new line of business. And in this case, her team is looking to monetize a new emerging technology. Now, the new line of business will require some new infrastructure, so beyond what they currently have. So, what benefit of cloud computing would be most relevant to her company? Okay, let's look at our last scenario, and this is going to be Jennifer. And Jennifer is the CTO at an insurance company, and this is just a medium-sized insurance company. And they are considering moving to the cloud instead of co-locating servers, which means where you're renting space in another data center. Now, they want to make sure that they have maximum control of the cloud servers, and they want to do that for security and compliance reasons. So in this case, what cloud computing model would they need to leverage? So stay tuned in the next clip. We'll go ahead and run through each of these scenarios and explain the answer as well as why that's the right answer for that scenario. So we've covered quite a bit in this initial module here in this course, and I want to quickly review each of the things we've covered before we dive in and take a look at our scenarios. So first of all, we reviewed the course resources. We looked at the guided outline, and we also understood how we would be positioning scenarios within the course. Then we created an AWS account for personal use. Following that, we examined how organizations leverage traditional data centers, and we focused on a fictional company, Globomantics, and how they were looking to deploy a new professional social network. Following that, we explored the benefits of cloud computing, and then we reviewed the different cloud computing models, and finally, we understood the cloud computing deployment models. So with that said, let's take a look at our scenarios. So our first scenario was Roger, and his company was running their own data center where they were managing their virtual servers with VMware, and then they wanted to also work alongside AWS in the public cloud. So which cloud deployment model would his company be following? Well, the answer to that is hybrid cloud, because they were using both a private cloud in their own data center and a public cloud, being AWS. Next, let's take a look at Eliza, and they were looking to monetize a new emerging technology. So with this new line of business and the new infrastructure that would be required, what benefit of cloud computing would be most relevant to her company? Well, the answer here is the pay-as-you-go concept, transitioning from that large upfront investment to a variable cost. This way, they can try out this new emerging technology, and they can try it out at a small scale and only pay for what they're using, instead of having to make a large upfront capital investment. And as mentioned, we'll be talking through the economics of the cloud in a later module within this course. Next, Jennifer is the CTO at an insurance company, and they were looking to move to the cloud, but they wanted to make sure they had maximum control of their cloud servers. So which cloud computing model would they need to leverage? Well, in this case, it's going to be Infrastructure as a Service, or IaaS, because they want to have maximum control. So just like they were running these servers in their own data center, and probably for security and compliance purposes, given that they're an insurance company. So in this case, instead of choosing to do platform as a service or software as a service, they would fully take advantage of infrastructure as a service to make sure that they had that maximum level of control. So next, we're going to be talking about the AWS global infrastructure. And that just means we're going to be looking at how AWS deploys its infrastructure globally, and then how they make those different bits of infrastructure available to us to build solutions on the platform. So we're going to talk about 4 distinct areas of the AWS global infrastructure. First, we're going to be discussing the concept of regions. Then we'll be discussing availability zones. We'll take a look at local zones, and then we'll take a look at edge locations. So over the course of this module, we're going to first be reviewing the elements of the AWS global infrastructure. We'll start off by understanding the use of AWS regions. We'll then be understanding availability zones within AWS regions. We'll also be taking a look at a newer concept, which is the use of local zones. We'll then be reviewing the purpose of edge locations, and we'll take a look at how you can utilize the AWS global infrastructure visualization. So next, I'm going to be introducing 2 very key concepts of the AWS global infrastructure. The first is AWS regions, and the second is availability zones, and you'll see that these are very closely connected. So first of all, let's take a look at AWS regions. Now, the first thing to note with a region is that each of them are located within a specific geographic location. Now, you might think, oh, that means they have a data center there. Well, no, in this case, each geographic location has a cluster of data centers, so more than just one. And as of the time of this recording, AWS currently has 30 regions that have been launched around the globe. So here we can take a quick look at these, but I'm also going to show you in a bit where you can go to get an always updated map that shows you where the regions are located. But next, let's talk about another concept, availability zones. So first of all, within an availability zone, it contains 1 or more data centers. In addition, multiple availability zones are included with each AWS region. And this is different from some other cloud providers where availability zones is an optional feature. Here, every AWS region does include multiple availability zones. Also, it's important to note that these availability zones, they are located within the geographic area of the AWS region. So when we have a region like the one in Northern Virginia, all of the availability zones will be located within that region. These availability zones have redundant power, networking, and connectivity. So the reason that these exist is to make sure that you generally wouldn't ever have a scenario where an entire region would go down. And we'll talk more later about how these availability zones enable high availability for your applications. And there are currently 96 availability zones globally. Now let's just take a high-level look at some regions within the United States. So first of all, we have 6 different regions that exist within the United States. So the availability zones here are associated with the region that you can see that they're closest to. And these availability zones provide a level of failover to ensure that you have high availability for the applications that you deploy. And let's talk about a few terms here. First, we have the term of availability. And this is the extent to which an application is fulfilling its intended business purpose. And applications that are highly available are built in a manner where a single failure won't lessen the application's ability to be fully operational. Now, there's another concept that you need to be aware of, and that is how we name AWS regions and availability zones. So you might see something at some point like US East 2A. So let's talk about what this means. Let's break down each of the components. So first, you might guess that US in the beginning stands for United States, and you would be correct. Here, this is going to be the area. We then have a sub area underneath that main area. So in this case, this would be on the eastern side of the US. We then have a number because we might have 2 different regions or more in a specific area. And that is the case. We have both a US East 1 which is in Northern Virginia, and a US East 2, which is in Ohio. But we also have a letter at the end, and this is for the availability zone. So, for example, if you had two availability zones you were considering in Ohio, you would have US East 2A and US East 2B. Now, that's the complete name, but if we leave off the letter, that gives us the region name. So when we're talking about a region, we would say US East 2 as a region. But if we want the entire availability zone name, it would include everything from US East all the way to the end to 2A. Now, I want to just show you, here is a list of the currently launched AWS regions. Now, I purposely left a few off here. There are some regions in China and those that are used by the US government, and those are not on the list because those aren't available for everyone to use. So next, I want you to be familiar with two additional concepts when it comes to AWS global infrastructure. The first is the concept of a local zone, and the second is a wavelength zone. So let's take a look at these two concepts. So an AWS local zone places compute, storage, database, and other select AWS services closer to end users. Each AWS local zone location is an extension of an AWS region. AWS local zones provide a high bandwidth secure connection between local workloads and those running in the AWS region, allowing you to seamlessly connect to the full range of in-region services through the same API and tool sets. Now, that might not make a lot of sense yet. Let's take a look at a map and see if I can help drive this point home. So here you can see the 6 different AWS regions that I included on the map in the previous clip. Now, in this case, we have 2 primary regions that are going to be associated with local zones. So here I'm going to fade the others out. And these 2 that we're looking at here is we have US West 2 and we have US East 1. Now, I'm going to go ahead and show you all of the current local zones that exist within the United States. And you might notice that these actually are in key areas such as Dallas and Houston and Miami and Chicago and Seattle and Los Angeles, as well as many, many more. Now, the way this works is that highly efficient connection that exists between those specific local zones and the region can be demonstrated this way. Here you can see that a vast majority of the local zones on the West Coast actually link up with US West 2 as their parent region. And what we see over on the East Coast is that all of those link up with US East 1 as its parent region. So why would this matter? Well, if you're trying to build an application in Chicago, you might want to make sure you have some infrastructure running close to the end users that are going to be in Chicago. And you could accomplish this by utilizing a local zone, in this case, the one in Chicago, partnered with the parent zone, which is US East 1, which is located in Northern Virginia. So next, I want to talk to you about wavelength zones. Now, wavelength zones are AWS infrastructure deployments that embed AWS compute and storage services within communication service providers' 5G networks. So application traffic from 5G devices can reach application servers running in wavelength zones without leaving the telecommunications network. So if you're looking to create a highly efficient application that can run off of wireless providers on a 5G network, this is what wavelength zones were designed to do. So next, we're going to discuss another element of AWS global infrastructure, and that is AWS edge locations. But to understand this, I also need to introduce you to another term. So points of presence are elements of the AWS global infrastructure that exist outside of AWS regions. Now, these elements are located in or near populated areas, and specific AWS services use them to deliver content to end users as quickly as possible. Within the overall points of presence, there are 2 types of infrastructure: edge locations, which we'll be focusing on here within this clip, and regional edge caches, which we won't be covering to prepare you for your cloud practitioner exam, but it is important to know that they exist. So at the time of this course recording, there were over 410 points of presence globally within the AWS global infrastructure, with over 400 edge locations and 13 regional edge caches. Now, just as a personal note here, when I first started creating content around the cloud practitioner course, I believe that we had 100 different edge locations globally. So this has multiplied by a factor of 4. Let's talk about why that's significant. First of all, these edge locations are used as nodes of a global content delivery network. And there are specific services that leverage these edge locations, primarily Amazon CloudFront and Amazon Route 53. And you'll learn more about these services and what they do within the next course. But there are over 400 different locations, as I previously mentioned. Next, it allows AWS to serve content from locations closest to users. So for example, if you wanted to create a single page application and you wanted to be sure that it could be served as quickly as possible, and let's say you have an end user in Copenhagen, well, you could make sure that this is being served from the edge location in Copenhagen via Amazon CloudFront instead of making them go to wherever the next closest AWS region would be. So next, I want to show you a resource that can help you actually plan how you utilize the AWS global infrastructure. So here, over the course of this demo, we will be reviewing the method of accessing the AWS global infrastructure site. We'll also be reviewing regions and availability zones within the site, as well as the edge locations. So I want to show you the AWS global infrastructure site. Now, you can access this site utilizing the short URL that I've included here on the screen. Now, if you scroll down from this main part of the page, first of all, you'll notice here some key statistics about the global infrastructure, including the number of regions and availability zones and points of presence. But if we scroll down, we're going to see a map. Now, there doesn't seem to be a whole lot going on with this map, and so you might think this isn't of huge value, but I believe that as you are creating infrastructure on AWS, this is going to be an extremely valuable tool for you to take advantage of. Let's say, for example, that you want to build a solution in Asia and Australia. Well, if I go in here to the map and I mouse over this area, you can see that all of Asia and Australia actually lights up. Now, I'll point out here that first, at a high level, we can see the different regions that exist. So for example, I could see that Hyderabad has a region that launched in 2022, and it has 3 availability zones. I can also see another one in Mumbai, and this one has 3 availability zones and 1 local zone. And I can see that for all of the regions. Now, some of the regions aren't always available to you. For example, if I look here at the region here in China, this particular one requires you to opt in and not everyone can have access. It will also show you regions that are planned. We can see, for example, that a region is planned here in Thailand, as well as in Melbourne and in Auckland. So with that said, that information in and of itself is valuable. But if we click into an area, we can see a lot more information. Here, I can see a listing of all of the regions, and then in parentheses, I can actually see the number of availability zones associated with that region. I also here can see all the edge locations that exist, as well as the regional edge caches that exist within this area as well. And at the top, I can get here just some key statistics. So we can see at a very high level, there are 35 availability zones within 11 geographic regions, 34 edge network locations, and 5 regional edge cache locations. And you can do this for every geographic area that's included here on the map. So we can see the same here for North America. We can see, for example, that there are 25 availability zones within 7 geographic regions, 44 edge network locations, and 2 regional edge cache locations. So for example, if I look at Atlanta, Georgia, I might not have a region that is super close to Atlanta, Georgia, but I can see that there are 3 different edge locations there, ensuring that if I'm using a service like CloudFront, that my data is going to be extremely close to the end user. So this is how you can utilize the AWS Global Infrastructure Visualization to help plan how you utilize the AWS infrastructure that exists globally. So next, we're going to cover some scenarios here, and these scenarios are going to help you see how well you have retained the information that has been covered in this module. Now, as a reminder, we're going to go through the scenarios here, and I'm not going to go through the answers until we get to the next clip. So be sure that you take time to write down your answers before you move on to the next clip. For our first scenario here, we have Jane. And Jane's company is looking to transition to AWS. And they're going to start with just a few workloads. However, it is a requirement to store backup data in multiple geographic areas. So, which element of AWS Global Infrastructure will best suit this need? Okay, moving on. Next, we have Tim. And Tim's company serves content through their site to users around the globe. And they're looking to optimize performance to users around the world. Now, they're looking to leverage a content delivery network, or CDN. So which element of the AWS global infrastructure will be used in this case? Okay, one more to go. Ellen's company is transitioning one of their legacy applications to AWS, and this application requires uptime of at least 99.5%. They want to be sure that any issues at a single data center don't cause an outage. So, which element of the AWS global infrastructure supports this need? Now, I'll be going through the answers in the next clip. So we've covered quite a bit in this module in taking a look at the AWS global infrastructure. So before we move on to the answers to the scenarios that I presented in the previous clip, let's just take a quick look back at what we have been able to cover. So first of all, we reviewed the elements of the AWS global infrastructure. As a part of that, we understood the use of AWS regions and why having these different geographically based regions helps people create applications that can be highly available. And as a key part of that, we talked about the availability zones that exist within those AWS regions and how they make sure that even if you have an availability zone that goes down, the entire region still stays up and running. We also talked about the use of local zones and how they partner with parent zones to help bring content to end users. We also talked about the purpose of edge locations, especially as it ties into a content delivery network or CDN. We also utilized the AWS Global Infrastructure Visualization to help understand which infrastructure elements exist at what place in the world. So, with that out of the way, let's go ahead and visit our scenarios. So, first up, Jane's company was looking to transition to AWS. And if you remember, we were trying to determine which element of the AWS global infrastructure will best suit the need that they have. Well, in this case, the answer is AWS region, because there are regions that are geographically based. And so even if they're deploying workloads within a single region, they can actually save that backup data across multiple regions. Maybe they're running in Northern Virginia with US East 1, but they want to store that backup data in US East 2, which is in Ohio, as well as US West 2, which is in Oregon. The next scenario here, we had Tim, and he was serving content through their site to users around the globe. So to do this, which element of the AWS global infrastructure will be used? Well, in this case, it's going to be the edge location. And the key word here is Content Delivery Network, or CDN, because here Amazon CloudFront, which is the Content Delivery Network solution on AWS, utilizes edge locations to make sure that that content is as close to possible to those end users. And if you remember, we have over 400 of those locations that exist globally. Now, for our final scenario, we had Ellen. And if you remember, her company was transitioning a legacy application to AWS. So which element of the AWS global infrastructure supported her need? Well, in this case, the answer is the AWS availability zone, which will sometimes be referred to as an AZ. And the reason is because here, if we need to have a high uptime, that means we need our application to be highly available. So by taking advantage of multiple availability zones within a single region, we can help make sure that the application won't go down if just one data center has a problem. The availability zones help make sure we can create applications that are indeed highly available. So in this module, we're going to be talking about the economics of the cloud, and we're going to cover several topics. First of all, we're going to be looking at the funding differences between traditional data centers and the cloud. And then we're going to look at the AWS provided tools for the organization of our costs. And then we'll be utilizing AWS tools to actually make a case for moving our organization to the cloud. And then we'll be exploring AWS costs using the AWS provided tools. Now, to start off with, I want to talk about two terms that have to do with how we finance our projects. The first term is capitalized expenditure, or CapEx. So let's say you're building your own data center. So when you're building that data center, you have to make a large upfront investment, and that's going to cover buildings and servers and supporting equipment. Now, this type of expense is there to attain a fixed asset, and we're going to call that a capitalized expenditure. Now, the other type of expenditure we're going to talk about is an operating expenditure, or OpEx. And this has to do with the regular day-to-day expenses of your business, and these are OpEx. So when you build a data center, your ongoing costs around connectivity and your utilities and your maintenance costs, those would be considered OpEx. Now you might be saying, what does this have to do with the cloud? Well, let's dive into that. Let's talk first about having your own data center. So if you have your own data center, let's say that you decided to launch an application within that data center. And let's say that here is your demand. It starts off pretty low because it's a new application, but then it continues to grow. And you can even see, for example, that between month 2 and month 3, it more than doubled. And so with this, we're going to now look at our capacity. So our data center was built to handle an initial amount of capacity. And we're noticing here that there's a few problems. First of all, we have unused capacity. So when our data center launched and we then launched our application within the data center, we had to account for the amount of capacity that we believed our application needed. So in the beginning, before users were leveraging our application, there was a lot of unused capacity. And that's capacity that we're paying for whether it gets used or not. But then we have another even more critical issue, and that's that we have demand over capacity. And that means in these cases, we have users that are getting denied access to our application because we don't have the data center power that we need to actually serve those users. So if you notice, between month 4 and month 5, we decided to make an investment and build out our data center to handle more capacity. Now let's talk about how you fund this type of initiative. So initially, when you're building out your own data center, you're first going to have a very, very large upfront capitalized expenditure or CapEx to build out your data center, to take care of that building and all of those servers that are going to be needed. Then you're going to have an operational expenditure that's going to happen month to month. But if you notice, when we increased our capacity between month 4 and month 5, we had another large upfront capitalized expenditure, followed by an increased operational expenditure as we now have to operate more servers and more equipment. Now this is how it works with your own data center, but let's talk about how this works in the cloud. So let's say that we have the exact same application with the exact same demand in the cloud. Now in this case, we're able to do something different with capacity. We're able to make sure that we have just enough capacity to meet the demand that our users have for our application. And another thing is different. Let's look at the costs. So here, with the costs in the cloud, so there is no capitalized expenditure because we're leveraging the cloud. And here, our operational expenditure mirrors what we have in terms of the demand. So what does all of this mean? Well, let's compare and contrast our own data center and cloud infrastructure. So with our own data center, there is a large upfront cost that's CapEx. Also, there's a potential for either underused capacity or unmet demand. And in many cases, these are going to be inevitable unless you can predict the future. Also, increasing capacity takes time and additional investment. Because you have to order servers, you have to build onto your data center, you have to add additional cooling and networking and a lot of other things to support your data center. And that doesn't just happen overnight. So you're going to have situations where if there is a need for increased demand, there will be time that will elapse before you can meet that. Then, monthly costs in this case will map to predicted infrastructure needs. This is why I mentioned earlier that you need to be able to predict the future if you're going to go down this path. Because you're going to, in this case, have costs that align with what you think the demand will be. But now let's talk about cloud infrastructure. So first of all, there's no upfront investment. So you don't have that large CapEx at the front end because you're not building out your own data center. Next, you pay as you go for infrastructure. And this pay as you go concept is critical because it allows you to only pay for the demand that your users have. And it can scale to meet that demand. And that additional capacity can be provisioned immediately, which is a big difference to having to build onto your data center and add more servers. And another factor is that monthly costs will map directly to the user demand. So now that you have an understanding about the difference between working within your own data centers and working in the cloud, let's take a look at how we can organize and optimize our AWS costs. So first, we're going to be looking at one of the most critical tools for managing your costs within AWS, and that is the AWS Cost Explorer.
Now, it provides you with a user interface for exploring your AWS costs, and you access this user interface through the console in your browser. And it will provide you with breakdowns on your costs, including by service. And it's important to note here that, again, AWS is a collection of services. So if you're utilizing a service like EC2 for your virtual machines and S3 for your storage, you would want to know how much am I spending on each service. In addition, we have a breakdown by cost tag, and we'll talk about cost tags later within this clip. Now, one of the useful features of Cost Explorer is that it also provides predictions for the next 3 months of your costs based on your current usage. This can help you better understand what your monthly run rate is for the AWS services that you're leveraging. And here it also will provide recommendations for how you can optimize your costs. Now, you might want to utilize the console in the beginning, but if you wanted to automate aspects of this cost analysis, you can also access the same data via an API. Now let's talk about another service that works hand in hand with Cost Explorer, and that would be AWS budgets. Now, earlier within this course, we set a budget alarm, so you already have had some level of exposure to AWS budgets. But this utilizes data from the AWS Cost Explorer to plan and track your usage across AWS services. And it can track costs per service, service usage, reserved instance utilization and coverage, and savings plan utilization and coverage. Now, I understand that we haven't yet talked about reserve instances or savings plans, but we will be talking about those throughout the course of this learning path. Now, there are some tools that we can use to help plan our future costs. And first, we have the AWS pricing calculator, and we'll actually do a demo of this later within this module. But this gives some in-depth analysis of your potential costs by utilizing multiple AWS services for your cloud-based workloads. So let me explain that. Let's say you were looking to launch a social network for your company, and you believe you're going to need 5 different web servers, you're going to need 2 different database servers, and you're going to need 500 gigabytes of storage inside of a service like S3. Well, you can enter all of those factors into the pricing calculator and determine how much it would cost. You can even look at different ways to build it and then compare costs between the different approaches. So another approach we can take is when we're just looking to migrate existing workloads into the cloud. And there are tools you can use to actually make the business case for moving into the cloud. One of those tools would be Migration Hub, but it's not the only tool. But this gives you the ability to go through and make a business case for transitioning your workloads to the cloud by comparing costs from your own data center to what it would be in the cloud. In a future clip, we will examine the way you can utilize AWS tools to make the business case for moving to the cloud. So next, I want to highlight a couple of deprecated tools in case you see those listed in blog posts or other things, you'll know what people are talking about. Originally, we had the TCO calculator, which did enable an organization to determine what could be saved by leveraging cloud infrastructure. That's been replaced by some other tools that we'll talk about in an upcoming clip. Also, before we had the AWS pricing calculator, we had the AWS simple monthly calculator, and it did similar things to what the pricing calculator can do. It just couldn't do everything that the current pricing calculator can do. So if you see either of these, just know that these are deprecated tools. These in essence are previous generation tools that we no longer use. So let's talk next about AWS resource tags. Now, really, these are just metadata that gets assigned to a specific AWS resource within our account. We can give it a name and an optional value. So let's say, for example, with the use case I mentioned just a little bit ago, if we have a social network that we're launching and we have maybe 5 web servers, well, we could go in and just put web server as a tag on each of those. And then when we went in to look at our costs, we could say, okay, how much are we spending on everything that has the tag web server? But another common use case here is to include department, environment, or project. So let's look at that for a minute. Let's say that you have some internal applications that HR is using. What you can do is you could set a name of department, and then you could enter in an optional value of HR. Or we could break it down by environment. Many times when we build applications in the cloud, we'll have a testing environment and a production environment. So we could create a tag with the name environment, and the value could be either production or testing. Now, with this, you can utilize cost allocation reports to see your costs grouped by active tags. Now, this is something you can enable within Cost Explorer. Also, we can use the tags within Cost Explorer when we're looking at our costs. Now, there's another way that we can actually group our costs together, and that is with AWS organizations. And this allows organizations to manage multiple accounts under a single master account. So instead of doing what we mentioned earlier with department and having HR, for example, as one department, we could actually create a completely separate AWS account under a master account that is for HR. And in some ways, that makes tracking and access control even easier because it's in a completely separate account. Now, one of the features you get by using AWS organizations is consolidated billing. So this means that even if you have 100 different AWS accounts using AWS organizations under a single master account, you only get one bill. And we can see within this bill a breakdown of our costs by account. We also can go into Cost Explorer in the master account and we can see the breakdown of costs within each account and then even breakdowns further beyond that. And this also can enable organizations to centralize things like logging and security standards across multiple accounts. So next, let's talk about how organizations can actually build a business case for moving into the cloud from their own data centers. So let's talk about what you need to do to build a business case. First of all, you need to analyze your current workloads. You need to understand the applications and processes that you have running so that you can begin the process of forecasting what those infrastructure needs could be in the cloud. Now, we've already reviewed a tool that once we know what resources we need, we can use to determine the cost in the cloud, and that would be the AWS pricing calculator. But in this case, how can you streamline the process of analyzing those workloads and forecasting the future needs? Because then you ultimately can create a TCO analysis or total cost of ownership analysis of both options. Now, there are tools that help you in this process within AWS. First, we have Migration Hub, and this is a central location to gather information from multiple different AWS tools together to forecast your needed infrastructure. And you can use this information to begin to build out your business case. There's also a more in-depth option that goes even further in building out your business case, and that would be the Migration Evaluator. And this is an in-depth service to calculate your infrastructure needs and build a business case for the cloud. Now, there's a lot of discussion we could go into with each of these, but what I want you to understand at this level is to understand that these both are tools that can help organizations decide if a move to the cloud makes sense for them. So now we're actually going to walk through the process of using the AWS pricing calculator. And as a reminder, this is designed to estimate future workloads. Now, we did have an older tool, the AWS Simple Monthly Calculator, but this was replaced by the newer AWS pricing calculator, and that's what we'll be using here within this clip. So let's talk about what we're going to do exactly. First, I'll show you how to access the AWS pricing calculator in your browser. And then we'll talk through the process of estimating costs for a workload on the cloud using the calculator. We'll even look at how we can save and share the results with other people. So here I have my browser pulled up to the AWS pricing calculator, and you can access this with the URL that you see here on the screen. You don't need to be logged into an AWS account to use the AWS pricing calculator. So here I'm going to click the option to create an estimate. Now here we can see a lot of different options. Let's just take this piece by piece. First of all, we're going to say here that we want to work within the US East 1 region, which is in Northern Virginia. And it lets me know here that there are 148 different AWS services that are available here. So here, if we want to use a service, we can simply go in and enter the name for the service. Now, I'll add a caveat here. I know we haven't reviewed a lot of AWS services yet. So I'm going to enter in some information here, and you might not fully understand what those services are for just yet, but we'll be covering that in depth in the next course, Understanding AWS Core Services. But from here, let's use our social network example. Let's say that I need to have some web servers for my social network. So I'm going to spin up some virtual machines in this case. So I'm going to search for EC2 as a service. So I'm going to click here where it says configure. From here, I can enter in a description for this part of the estimate. So we'll say web servers. And then we can specify that we either want to do a quick estimate or an advanced estimate. Now, for the purpose of this demo, we're going to stick with the quick estimate, but the more you learn about AWS, you may want to go through the advanced estimate process, and it will be able to give you a more accurate description of what your future costs would be. Now here, we're going to say that we're going to use Linux servers, and let's say I want to have at least 8 vCPUs and 32 gigs of memory. And then it's going to give us a recommendation, which in this case is a T4G 2X large. Now, I realize that sounds like a foreign language, but this is a name given to an instance type for a virtual machine that we're spinning up. Now, I'm going to say that I want to have 5 of these, and these are going to be 100% utilized. Now, we have the option here to pick different pricing strategies. And again, I know we haven't been through this fully yet. I'm just going to leave the options that they have selected here. And I'm also going to say that I want each of those virtual machines to have a 20 gigabyte volume attached to them. Perfect. So now we can save and actually add this. So now that I have this in place, a portion of my estimate has already been added in. You can see here that I can see at the bottom an overview of my monthly cost and my total 12-month cost already. But now we also need to add in some database servers. So I'm going to go here and I'm going to say RDS. That stands for Relational Database Service. And I'm going to scroll down. I'll select the option for Postgres. So I'm going to hit Configure for this. And let's say that we're fine here with the size, a DB-M1 large, but let's say I want to have 3 different nodes. And I can scroll down here and see that I also want these to be 100% utilized, and we want to use the multi-availability zone deployment option. And that's going to give us the ability to have high availability with this particular database cluster. We're also going to say here that we want to use an RDS proxy, and I'm going to say that 30 gigabytes of storage for each node is going to make sense. We also could go in and add in backup storage. Let's say that we want to have an additional 40 gigabytes of backup storage, and we can just leave the rest of the values at their current defaults. So now I can hit save and add that to the service. So now you can see that the bottom has been updated to include an updated monthly cost and our total 12-month cost. Now I'm going to go ahead and click the option to view the summary. This is going to give me a complete breakdown, and we can see here that we have Amazon EC2, we can see we have Amazon RDS, and in all likelihood, we would have several more things as well. We would need to calculate storage, and we would need to look at the data that's going in and out of AWS. But for now, this gives us a good baseline to work from. We could go in and we could add an additional service. We could go in and we could group different costs together. But for now, we have an estimate. And what we can do from here is we can actually export it. We can either export it to a CSV or a PDF file. But another great feature, and one that you'll find yourself using often if you're collaborating with other people to build cloud-based applications, is the ability to share these costs. So I'm going to click on the option here to share, and it first is going to tell me that this is going to be public data. It's going to be stored on public AWS servers, and it's going to give a link that doesn't require you to log in, because as you know, you don't have to log in at all to use the pricing calculator. So you'll have to agree to this before you're able to actually create a URL where you can access this estimate. Now, if you say, hey, I don't want my information to be public, well, you can simply export your estimate as a PDF or as a CSV file and then send it to whomever you'd like. But with this approach, you end up with a URL that someone else can utilize to go in and look at your estimate and then continue customizations based on that estimate. So next, we're actually going to get in and utilize the Cost Explorer within the AWS console. And we'll see how we can review our costs within our account utilizing this tool. So here in this demo, here's what we're going to be doing. First, I will show you how to actually access the AWS Cost Explorer within an AWS account. We'll then be reviewing charges by service for an AWS account. We'll be utilizing the predefined reports included with Cost Explorer, and then ultimately we will be downloading the data from the AWS Cost Explorer. So let's dive in. So I'm here in the AWS console, and I've actually logged into a different account than the one I created earlier within this course, because since we're looking at AWS costs, I wanted to give you an account that actually had some real AWS charges on it. So to get to Cost Explorer, I'm going to go under my name, and I'm going to select Billing Dashboard. Here within the left pane, I'll select Cost Explorer, and then I'll need to click this button here to actually launch Cost Explorer. So now we're inside of AWS Cost Management, and at a high level, you can see here on the dashboard, I have a current month, and you can see here on the dashboard, I have my current monthly costs as well as my forecasted month-end costs. And in some cases, this might be all the information you need. But when you're dealing with many different AWS services, you might want to dive into it a little bit more deeply, and that's where Cost Explorer comes in. So here I can see my daily unblended costs, and I'm going to click the button to view in Cost Explorer. So the first thing I'm going to do is I'm going to close the side panel here so we have a little bit more room to look at Cost Explorer. Now this is grouping my costs together on a daily basis, so I can see my daily costs across all AWS services. This is another thing that can be valuable, but a lot of times we're going to want to know what AWS service actually generated those charges. So you can choose to go in and group your costs by several different factors, but one of the things you'll often use is to group by service. And now I can see that I'm generating these charges from services like EC2 and AppRunner, as well as several others. Now I could choose to go through and look at more detailed information in the table below, but maybe I don't really want to know by service. Maybe I'm utilizing an AWS organization, which I am in this case, and I want to see each of the different accounts and how they're generating charges within consolidated billing. So I can actually click out of service, and instead I can say group by linked account. And in this case, I can see the different accounts and which ones are actually generating charges. Now I have some different accounts, including things like Cloud Builder Live, and that's a show that I actually do for Pluralsight. And so I can see that my demo account for that generates some charges. I have another account, which is my Pluralsight demo account, and that's what I use for all my courses. And you can see that there's several others that exist as well. But this enables me to see a complete breakdown by the different accounts that I have. And I can choose to group by many different things, including by region. I can do it by usage type. I can even do it by tags, which we talked about in a previous clip. And I could even choose to go through and change the date range and even change how they are grouped. But instead of going in and actually just generating these reports on the fly, I might want to take a look at some reports that AWS has already created for me. So I'm going to go back to AWS Cost Management. And from here, I can click the option that says Reports in the left pane. Now I can see here that there are reports that are already generated. Monthly cost by service, monthly cost by linked account. Let's just go ahead and take a look at monthly cost by linked account. Now I can see here that there is a report that's already created for me so that I can see this breakdown by linked account month to month. So instead of simply having to go in and do this every time I can utilize this report, I can even save my own reports and access them at a later time. Now, if I were to scroll down below the graph and see the table view, I can actually click the Download CSV button and I can download the actual data that is being used to generate the graph. And in that way, I can do my own analysis on the data inside of separate tools. I could even send this information to someone else who doesn't have access to my billing dashboard if I wanted them to explore our costs within AWS. So now we're going to apply these principles of cloud economics by looking at some scenarios, and you can judge how well you've absorbed the material that has been covered within this module. So grab those guided notes, grab a pencil, and be ready to jot your answers down. And I'll be reviewing the answers for these scenarios in the next clip. So here is our first scenario. And here we're going to be talking about Oscar. And Oscar's company has multiple departments that work within AWS. And in this case, finance is asking for a clean separation of AWS costs between departments. Now, currently all resources are included within a single AWS account. So what approach would meet this need for future costs with minimal effort? Okay, think about the answer for that one. And now let's look at scenario 2. So for scenario 2, Cindy's company is considering a transition to the cloud. They currently have 2 physical data centers that they own and maintain. Stakeholders are questioning whether this approach will save money. So which approach should Cindy take to make a case for the cloud? Okay, one more to go. Here we have scenario 3. And in this case, we have William, and he is a web developer at his company. And given some recent downtime, he is looking at moving their site to the cloud. But finance is asking for an estimate of costs for this transition to AWS. So what approach should William take to get this data to his finance team? So in the next clip, we'll walk through the answers to these scenarios. So here we've covered quite a bit in the world of cloud economics on AWS. So before we dive in and explore the answers to the scenarios, let's just take a step back and let's take a look at all the things that we've been able to cover here within this module. So first of all, we understood funding differences between traditional data centers and the cloud. We also utilized AWS tools for cost organization. We then examined the AWS tools that you could use in making a case for moving to the cloud, and we actually explored real AWS cost using the AWS provided tools. So now with all of that information behind us, let's take a look at the scenarios and their answers. So first we have Oscar, and if you remember, he was looking to provide data to finance that was cleanly separated between departments, and he needed to do this with minimal effort. Well, what would he do in this case? In this case, he would create and leverage a resource tag for each department. And you might say, well, wouldn't they be more cleanly separated by using AWS organizations? And that's a great point. But moving resources between different accounts would be a bit of additional effort required here, and he was looking to do something here with minimal effort. So in this case, the tag approach makes sense. And next we have Cindy. And Cindy's company was considering a transition to the cloud, but she needed to make a case for the cloud. So what would she do here? Well, in this case, she could look at utilizing AWS Migration Hub or Migration Evaluator to build her business case for moving into the cloud. Okay, last one. Here we have William. And if you remember, he needed to provide finance with an estimate of cost for transitioning an existing workload into the cloud. So how should he do this? Well, in this case, he can utilize the AWS pricing calculator and then share results with his finance team. So next, we're going to talk about how you support your AWS infrastructure once you transition some of your workloads to the cloud. So over the course of this module, here's what we're going to be covering. First of all, we'll be understanding the tools that are provided by AWS to support your workloads in the cloud. And we'll be reviewing the AWS support plan tiers. Then, we'll be reviewing AWS Trusted Advisor recommendations and exploring the AWS Personal Health Dashboard. So next, let's talk about the tools that AWS provides to support your infrastructure. And anytime we're talking about support, we're really talking at a high level about AWS support, which is the service that enables you to file support requests with AWS resources. However, within AWS support, there are two additional services that are also made available to you. The first is the AWS Personal Health Dashboard, and the second is AWS Trusted Advisor. So let's take a look at each of these three services. So first of all, we're going to talk about AWS support. So with AWS support, it enables you to get support from AWS resources for your workloads that are running in the cloud. And it is provided in different tiers based on your need and the scope of your need. Now, it includes tools to provide both automated answers and recommendations, and we'll look at some of those recommendations later within this module. Now, the next service is the AWS Personal Health Dashboard, and it is going to provide both alerts and remediation guidance when AWS is experiencing events that may impact you. For example, if there is a partial outage of a service within a region, this is where you can gain insight on that and understand how this could affect your infrastructure. Now, the next service is the AWS Trusted Advisor, and this is a powerful automated tool that enables you to check your AWS usage against best practices. So in many cases, if you are regularly implementing the recommendations that Trusted Advisor provides, you may even eliminate the need to file a support request. It can be accessed from the AWS console, and different checks within Trusted Advisor are provided based on the AWS support plan tier that you have. But all AWS customers, even ones without a paid support plan, get access to 7 core checks within Trusted Advisor. Now, the Trusted Advisor checks are really divided into 5 different categories. The first is cost optimization. The second is performance. The third is security. Then we have fault tolerance, and finally, service limits. And so if you have a support plan that supports all of the checks, you can gain guidance in each of these areas for your workloads that are running on AWS. So now that we've discussed the different services that AWS provides to support your infrastructure in the cloud, we're now going to break down the specific AWS support plan tiers that are included. Now first, we need to understand the differences between the different support plan tiers. And it really falls into four key areas. The first is communication method, the second is response time, the third is cost, and the fourth is the type of guidance offered. So let's look first at the entry-level support plan, AWS Basic Support. Now, AWS Basic Support is provided for all AWS customers, and you have access to Trusted Advisor, to the 7 core checks within Trusted Advisor. You also get 24/7 access to customer service, documentation, forums, and white papers. However, you'll need to note here that you don't have access to AWS support engineers for your technical implementation questions. You do, however, get access to AWS Personal Health Dashboard, and with this plan, there is no monthly cost. However, if we move up a level, we get to AWS Developer Support, and this is targeted at an individual developer that's looking to get support for running their workloads in AWS. It does include all the features of basic support, but you also gain business hours email access to support engineers. However, we'll talk in a minute about the response times between the different support plans. Now, developer support is limited to one primary contact, so that individual needs to be the one to actually file the support requests. It starts at $29 per month, but it is tied to a percentage of AWS usage. So if you have a lot of AWS resources that are currently deployed, you may end up paying more than $29 per month. Next, we have AWS Business Support, and this includes all of the features of developer support, but it also adds in a full set of Trusted Advisor checks. It goes quite a bit beyond the 7 core checks that are just provided with basic and developer support. You here have 24/7 phone, email, and chat access to support engineers. So if you want to be able to pick up a phone and actually call an engineer, this becomes the first tier where you are able to do that. But you also have access here to email and chat. Next, we have unlimited contacts. So this is not just limited to potentially your root user. It allows you to let all of your resources have access to the support center and file support requests. Now, it also provides third-party software support. So if you're in a scenario where you want help in deploying a third-party piece of software onto AWS, this is the tier where you can start to get that access. Now, it starts at $100 per month, but just as the previous plan, it is tied to your AWS usage. So with more AWS usage, you would end up paying more than just $100 per month. Now, the last support plan is AWS Enterprise Support, and it includes all of the features of business support. It also includes a designated technical account manager, so a single individual that can become your point of contact for the account. Now, it also includes a concierge support team. Now, this starts at $15,000 per month, but it is also tied to your AWS usage. Next, let's review one of the most important aspects of comparing these different support plans, and that's the support response times. So we have 5 different categories that are provided by AWS in terms of their response time. General guidance, when we simply have questions that we need to have answered. System impaired, where something is not working as it should. Production system impaired, when we actually have a production system that is not performing at its desired capacity. Production system down, meaning that we actually have a production system that is completely non-functional. And finally, business critical system down, meaning that this is a core system for our organization and it is completely down. So in terms of the developer support plan, we're able to provide support response times across 2 of these categories. So within 24 business hours, we should be able to receive a response for general guidance and 12 business hours for system impaired. Now, with the business support plan, the first thing you'll notice is we're dropping the business hours designation here. We're actually talking here about just hours. So within 24 hours, we should have general guidance questions answered. Within 12 hours, we should have a system impaired response. Within 4 hours for production system impaired and 1 hour for production system down. But when we transition to enterprise, we're going to see this expand all the way down to our 5th category. So within general guidance, again, 24 hours, with system impaired, 12 hours, production system impaired, 4 hours, production system down is 1 hour, but For business critical system down, here we're able to see that there is a 15-minute response time provided if you have the enterprise support plan. So now that we've reviewed AWS support, we're actually going to dive into the AWS console and review some of the services that are provided as a part of AWS support. So here in this demo, we are first going to be accessing AWS Trusted Advisor in the console. And then we'll be reviewing the AWS Trusted Advisor recommendations. Now, following this, we'll be accessing the AWS Personal Health Dashboard and then reviewing the information provided in the Personal Health Dashboard. So let's dive in. So I'm here in the AWS console. I've already logged into the test account that I created earlier within this course. Now, I want to point out a few things. With the widget configuration that we have here, we're going to see little bits of information from the tools that we're looking for just here on the homepage of the console. For example, we can see our personalized health view here under AWS Health, and we can go directly to there from this link. And we also can see Trusted Advisor, and we can click on it to go directly to Trusted Advisor from here. But I want to show you another way that you can navigate through the console. You can simply type in the search bar above. So first, I'm going to search for Trusted Advisor. So I'll type in Trusted, and I can click here on this service. So here I can see that there are some recommendations already. But before we get to that, I want to point out here on the left pane, you can see that we have the 5 categories that we mentioned earlier: cost optimization, performance, security, fault tolerance, and service limits. Now, because here we're simply using a basic support plan, we are only going to see recommendations that are included under security and service limits. But if we were to upgrade the plan, then we would get more checks. However, we'll be able to see what some of those checks would be when we're examining Trusted Advisor here. So first of all, you can see that we do have a recommended action that we need to set up multi-factor authentication on the root account. And so we can actually see how we go through this process by simply following the steps here within Trusted Advisor. We can also see here there are just some areas that would require some investigation, maybe not immediate action. And we can see here that we're discouraging the use of the root user access. And so they want to see that we have at least one IAM user, just for example. However, you can see here at the bottom, if we did upgrade our AWS support plan, we could get access to all Trusted Advisor checks. Let me go through here, for example, and click on security. Here you can see the things that it is checking for our account, things that are included in those core checks. But if I scroll down here, we'll see that we can now see the items that it isn't currently checking because of the support plan that we have. So you can begin to understand the full scope of the capabilities that can be provided by Trusted Advisor if you did happen to have a bigger support plan than the one we currently have configured on this account. So I'm going to go ahead and scroll back to the top. And from here, you notice we also have the ability to actually download those checks. So if we don't simply want to use them here in the console, but we want to save them for later, we can get that information here directly from the console. Now I'm going to move away from Trusted Advisor, and I'm going to go back here to the home page of the console. Now I could just click on AWS Health Dashboard here under my recently visited services, but again, I want to help you navigate through the console. So here we're going to type in Personal Health, and we can see that the AWS Health Dashboard shows up here at the top of the list. And you can see here that for this particular account, there have been no recent issues. And that makes sense, to be honest, because I haven't configured any resources yet within this account. However, we can see some of the issues that have happened recently under the event log. For example, I can see here that there was an operational issue with EC2 in Northern Virginia, which is the US East 1 region. So I'm going to go ahead and click on this issue, and here we can gain a summary of when the issue was reported and when it ended. We can see the summary of what actually was happening here. So for example, we can see that some EBS volumes, which stands for Elastic Block Store volumes, experienced degraded I/O performance within the region. The issue has been resolved and the service is operating normally. So this is very beneficial information if you're utilizing this service and you want to know why something isn't working exactly as it should have been working. And so you get all of this information here within the health dashboard. And there's a lot of different ways you can get access to this information. As I showed you earlier, this can even show up on the home page of the console when you log in under the widget for your AWS Health. So hopefully here you've been able to see how we can leverage multiple tools that are included within the AWS console to support our use of the platform. Now, when organizations make the shift into the cloud, they quickly find that they're going to need some help because in most cases, they really want to answer the question, are we doing it right? And sometimes that's more than can be handled in just a support request with an AWS support plan. And so there are 3 resources that can be very helpful for organizations that are in this position. And to be honest, these are also resources you should be familiar with for the exam. So the first resource for organizations that are looking to answer that question about whether or not they're doing it right is the AWS Quick Starts. Now, each Quick Start provides step-by-step deployment instructions for a common technology platform into AWS. This is a great place for organizations that are using a standard platform and just want to know if they're deploying it in the right way. But in many cases, organizations are also going to want to bring in third-party subject matter experts to come in and help with their migration to AWS. And if you want to find trusted third parties that have been vetted by AWS through their partner program, you can take advantage of the AWS Partner Network consulting partners. Now, these people don't work for AWS, but they do work for a consulting company that has been vetted. And next, if you want to work directly with AWS resources, you can choose to take advantage of the AWS Professional Services team. So here, these are 3 resources that can help organizations move forward with their migration into the cloud. So next, we're going to be taking the knowledge that we've gained in this module in terms of AWS support, and we're going to be applying it to some real-world scenarios. And our first scenario here has to do with Sylvia. And Sylvia's company is in the process of moving multiple workloads into AWS. Now, one of these workloads is a mission-critical application, one that they want to be sure they maximize the uptime of. Now, her CTO has given her some specific guidance in saying that they need to be able to call support 24 hours a day. Now, with all of these criteria here, the question that he is asking her is, what is the most cost-effective support plan that meets this criteria? Now, next, let's look at Edward. And his company is evaluating AWS for some future workloads. Now, one of these future workloads that they're planning would be supporting multiple offices globally, so it would be in use 24 hours a day. And the company wants to be able to call, text, or email support if any issue occurs. Now, because this is going to be so mission critical for their company globally, they want to be able to get a response within 15 minutes if there is a complete outage of this infrastructure. So for Edward and his company, what is the most cost-effective support plan that meets the criteria? Okay, one more of these. We're going to be talking about William. And we've talked about William before. He is a web developer at a company. But in this case, we're going to be talking about William's personal account that he is using for a personal project on AWS. Now, because in his day job, he works in AWS, he doesn't expect he's going to need technical guidance from AWS. However, he does want access to AWS Trusted Advisor and the core checks that are provided. So for William, what is the most cost-effective support plan that meets his criteria? So now we're going to take a minute and review what we have covered within this module. And in addition to that, we're going to go through and talk about the solutions to the scenarios that we introduced in the last clip. So over the course of this module, we started off by understanding the tools that are provided by AWS to support workloads in the cloud. And then we reviewed the specific AWS support plan tiers that they provide. We then reviewed AWS Trusted Advisor recommendations, and we looked at the different categories of recommendations that are provided. And we also looked at the difference between the Trusted Advisor checks that are included within the basic and developer support versus the business and enterprise support tiers. And then we explored the AWS Personal Health Dashboard. Now let's dive into our scenarios. Scenario 1 had Sylvia needing to recommend a support plan for her company, and we were specifically looking at the most cost-effective support plan for her criteria. And the answer to this one is business support. But let's talk about why. So first of all, her CTO said that they needed to be able to call support. So first off, we know that if we're calling support, we have either a business or an enterprise support plan, because the developer plan only includes email access, and the basic support plan does not include access to support engineers for technical implementation questions. So because of this, we know we are immediately dealing with one of those two support plans. Now it says that she needs to be able to call support 24 hours a day. Well, in this case, that works for both business and for enterprise. So when we're looking at this, if we're looking at the most cost-effective support plan, we know that business support would be more cost-effective than enterprise support. And in this case, she doesn't have any requirements that would only be met by enterprise support. So next, let's look at Edward. So Edward's company, again, is evaluating AWS for future workloads. So for him, what should he recommend? Enterprise support. Let's talk about why. First of all, if we look at it, it says the company needs to be able to call, text, or email support if an issue occurs. Just as before, we know that this means that we are looking at either the business or the enterprise support plan. However, the key here is the company wants a response from an issue within 15 minutes if there is an outage. That means that the enterprise support plan is the only option, because that's going to give us that 15-minute increment if we have a mission-critical system down. Now next, let's talk about William. And William has an AWS account for a personal project, which is separate from what he's doing for work. And he doesn't think he's going to need technical guidance, but he does want access to the AWS Trusted Advisor core checks. So what would his support plan be? Well, in this case, we're going to say basic support. So the general support that is provided for anyone that has an AWS account. This includes access to the 7 core checks that are provided by AWS Trusted Advisor. Now, it doesn't provide technical implementation assistance. He can't email a support engineer. However, in this case, he doesn't believe he's going to need it. So he can choose to leverage basic support until he has a need to use one of the paid support options.
Now let's talk about what comes next and how you get ready for the exam. The first thing you'll need to do is you'll need to make sure that you don't sign up for your certification exam until you've completed all 4 courses in this learning path. Later on in this path, we'll walk you through the entire process of getting signed up for the exam and how to get ready for taking the exam. Now, that being said, what you can do now is you can go through and study the guided notes that you've taken throughout this course. That will give you the material that you need to get ready for the exam. And then you're going to be ready to move on to the next course, Understanding AWS Core Services. And please don't skip the last course in this path. This is truly the differentiator, where it will walk you through how to get ready for the exam and how to think about the questions that you'll find on the exam. And it will walk you through 2 complete sets of questions to help you evaluate whether or not you're ready to take the exam. So I'm excited for you to go ahead and take your next step on your journey to becoming an AWS certified cloud practitioner.